Well, what I'm going to do here, I think well is a little bit better than okay. What I'm going to do here is my goal is to derive this formula. I'm going to do this geometrically using this picture. And the reason I'm doing this is just, again, to give you another way to see where this formula comes from. And an exam question might be exactly that. Show me where the integration by parts formula comes from, either using this method, the geometric method, or the method we used in class last week. So here's the picture. What I have here is I have this box, and the area of this box is going to be u times v. So I'm thinking of this as the width, and this is the length. So the area of the box is w times L equals u times v. Okay. Now, on the other hand, the area, we can get it by integration. It's equal to this integral right here, area under this curve, where that's my orientation. So I'm in the y, or in this case, v world, plus this area, where I'm in the what we would normally call the u world. I mean the x world, but it's the u world. Okay, so in other words, this is another. So the area is going to be integral 2, this one here, plus integral 1. So this integral right here is equal to integral. We're integrating with respect to v, and we get g of v dv. Now this integral here is integrating with respect to u, and so I get this integral is going to be f of u du. Now we're saying that g of v is u, so we get u dv, and then we get v is equal to f of u, so we get v du. Okay. But again, our area is equal to u times v, so what this tells me is that this integral is equal to this quantity right here, u times v. Okay, well, what does that tell me? Well, I need to get this formula, so I need to solve for this, which is this right here. So I subtract this from both sides. And that gives me uv minus v du, those cancel, is equal to integral u dv, which is exactly that. Okay, so again, what did I do? I thought of integrating in the uv, using the uv axis. I drew a box. I'm thinking of this is equal to u, this is equal to v, the length, and I broke that into two separate integrals, and then I integrated each one, gv dv, which is u dv. This one over here ends up being v f of u du, so I get this equation, and then just like before in class, I solve for this, and that's what I get. So there you go, another way to find integration by parts.